All right, so like we said, the equation for the asymptote is that horizontal line or vertical line that the graph gets super close to but never touches. So we can see that the asymptote is here because it's going through the y-axis. It starts with y equals. And since it's intersecting at -4, then it is y is equal to -4. Now let's look at the domain. Remember, domain are all the x values that belong to that graph. So if I were to put all of the x values of all of these points that are on this graph, we would start at -infinity and then go off all the way to positive infinity. So my domain, all my x values will be from -infinity to positive infinity, also known as all real numbers. But if we look at the range, if we look at all of the y values, now all my y values are increasing all the way to positive infinity. But if we look at the starting point, where do my y values start at? -4. And they can't equal to -4, so we can't put an equal sign in that inequality. So all my y values are greater than -4 and less than infinity. Okay, let's look at the next one. For these two, we want to see if they represent inverses. Now remember when we talked about inverses, if we reflect over the equation y is equal to x, then that means they're inverses. So let's go ahead and sketch y is equal to x. Start at 0, and then you're just going to draw a straight line where your slope is 1. And this equation is y is equal to x. So the first way you can do it is that you can visualize your graph reflecting across that equation of y is equal to x. And they look like they're reflecting. One way that you can determine if they are in fact reflecting is, let's look at one point. This point is at 3, 1. And if we get the inverse, we switch the x and the y, which is 1, 3, and we go to 1, 3, and there is a point here. Let's check another point. This point here is 1, 0. If we get the inverse, it's 0, 1. And this point here is 0, 1. So that's a way that you can check double that they are inverses. Choose points, your x becomes your y, and your y becomes your x. So in this case, they are inverses because one way that you can say is that they reflect across y is equal to x. And the second way is that you can say the point x and y values. Look at the next graph. Again, let's graph our line of reflection. So it starts at 0, 0, and we draw our line of reflection. And automatically we can see that they're not reflected over each other. So these are not inverses because graphs do not reflect across y is equal to x. Questions so far? All right, let's move on to the next one. For this one, it says to sketch the graph that represents y is equal to 6 log x minus 7 plus 2. Telling us to use decimals for this. And if you feel I'm going too fast or you're too shy to ask questions, again, I'm uploading this video so you can watch it again. And your test, when do you guys test? Tuesday? Tuesday, okay. So next class period. You want to go to a graphing calculator, and then we want to type in that equation. All right, so when you look at your graph, you want to look for some pretty points like this one. We're going to use 8, 2, and 7.50. And what number is it getting super close to but never touching on the x? If we look at the x, what number is it getting close to but never going to reach? 7. So that's actually where your asymptote is. So if we go back to our graph, we're going to plot 7.50, 1, 2, 3, 4, 5, 6, 7.50, and then 8, 2. And then we're going to draw a vertical line to represent our asymptote at 7. So this is x is equal to 7 because it is going through the x-axis at 7. And then we're going to continue graphing our line, getting super close to that asymptote, but never touching it. Any questions on that? All right, let's go ahead and go on to the next one. It says write the equation of the parent function y is equal to cubed root of x that includes the following transformations. When you write an equation, you first want to start with the parent function. So go ahead and write the parent function first, leaving some space to put numbers. Now, when we have a compression or a stretch, it is your A value. That A value is being multiplied in the front. So this vertical compression of 1/5, we're going to put it in the front, multiplying to the equation. Next, we're going to look at the left 5. Remember, anything that's a horizontal change will be horizontal change will be with the x, and remember, x always lies right, so we're going to say plus 5. So if it is left, we're going to say x plus my h. If it was going right, we would say x minus whatever that h value is. So in this case, we have to say x plus 5. It's very important that you put it in parentheses and that all of it is under the radical. So this part is important. Under the radical in parentheses. And then finally, we have down 8. So if it goes down or up, it is outside parentheses. So if it's down, we're going to subtract, and up, we're going to add. And make sure it's outside the parentheses. Any questions on that? Okay, let's go ahead and go on to the next one. The next one is expanding log properties. So we always identify our base first. Our base is 7. And then it's 7. Oh, geez, this is expanding. I'm so sorry. This is what we just did. We have 10 times x. So when we have a multiplication, are we going to add or are we going to subtract? Do you guys remember? Subtract. It's log base b of m times n is equal to, actually it's add, bm plus log bn. So we got the m and the n, and we add them. The next one, since we're dividing, we're going to subtract them. So the law tells us is we have log of the base. If we're doing m divided by n, that means we get the log of that base, m, minus log of that base, n. So the numerator minus the denominator. So this is going to be my denominator, this is my numerator. Start with log base 2x minus log. All right, let's move on to the next one. Now for this one, we're going to condense, so we're basically working backwards. Because we're adding, what does it mean about what we're doing to the x and the p? Let's go back over here. When we added, what was happening to the two numbers? Is it being multiplied or divided? Yeah, they're being multiplied. So here we're going to do log base 8 of x times p. And let's go on to the next one. This one's being subtracted. That means we're going to divide them. I'll write down multiply up here. So we've got 5 and 10. So log base x, and then the first number is my numerator. The second number will be my denominator. You may be asked to simplify. So this could actually look like log base x of 1/2. Any questions? Okay, let's go on to the next one. This one is rewriting into exponential form. This is what I was doing earlier. Miss Silva. All right, we start with our base. My base is 6. And then you just go all the way around. You go to after the equal sign, that's going to be my exponent. And then equals to, we go back to the other side of that equal sign, 36. And if they're giving you all numbers, you can even double check. 6 squared is 36, right? 6 times 6 is 36. So that's another way to verify if you get all numbers. Okay, let's go ahead and go to the next one and identify my base. My base is x. So we're going to write out x first. And then it's to the power of 0 is equal to, then we go back to the other side of the equal sign, and 1. And anything to the 0 power is 1. So that's how we verify that it's correct. All right, for this one, we're going to write it into log form. Again, we identify our base. Our base when it's an exponential form is this one. So we start with log base 5. And then we circle around to the other side of the equal sign, 25, just like we did before. And then go back is equal to x. Question so far? And I think that's halfway. Yes. All right, giving you guys a little break.